So on the back side of this review, we're finding the area between the curves. So for number 1, it says find the area of the region bounded by those two curves. Anytime I can use my calculator, I'm going to do it as much as I can on it. So y equals, type in my equations, 6 minus x squared. And my second one is x squared minus 2x plus 2. Zoom 6 to get my regular zoom screen back here. I've got a curve doing that, and a second one there. So I'm going to just draw a quick picture of it for my own reference to see what I got. I've got a curve going like that, and a second one that is working its way down. Not perfect, but you can see it. This is going to be the blue curve because it's got a negative x squared, so it's a negative parabola, and that is the upward parabola. So I'm trying to find the area between the two curves. I'm trying to find that answer right there. So in order to set that up, I'm going to take the integration in terms of x. The first equation the first thing I got to do is find the two intersection points. So second, calculate. I'm going to find my intersection points. So I want to know right here. So second, calculate intersection. Where these two cross, so somewhere in there, hit enter. Second curve, hit enter. Guess, hit enter. So my first intersection point is at x equals -1, so I'm going to go from -1 to my second intersection point. Move my cursor over here. There we go. To right there, enter, enter, enter. Oh, those are easy intersection points, good. Y equals 2. Oh, x equals 2, sorry. X equals 2. Okay, those are my two curves. Those are my two intersection points. The next thing I got to do is type in the first equation, or the top equation minus the bottom equation. So in this case, the top equation is the blue one. So I want to start with this 6 minus x squared equation. Okay, so for me, in my calculator, I type that in as y1. So if I called this one y1 and this one y2, in my calculator, I'm going to do y1 minus y2, or in other words, the blue equation minus the red equation. Once you've got it set up in your calculator, it should be easy. So math 9, from -1 to 2, and I want to do y1. So alpha F4, which is this trace button right here, y1 minus alpha F4, y2, dx, enter. My answer is 9. That is the area between those two curves. For the second one, find the area bounded between those two. Same setup. Just so you didn't have to watch me type it in, I added my new two equations. For y1, I typed in -x, and for y2, I typed in that. Graph it. See what happens. That's the -x line. And there's my other one. So this is the -x. This is the curved line. So just drawing a picture of what's going on. The blue graph is that -x line that goes like this. Not perfect, but okay. And it goes like this through the middle. We're trying to find the bounded region. So there's two of them, from there to there and from there to there. So I need to set up two separate integration problems. The first one goes from this intersection point to there in the middle. It looks like 0. Let's double check. Second, calculate the intersect point. Where do they intersect? So right there, enter, enter, enter. This is the x value. I need to store that as a, so it's at -3.6457, etc. So I'm going to store that as a in my calculator. Oh, I don't know where I got that 5 from. Sorry. 3, 6, 4, 5, 7, ... I want to store that. So second, quit. I want to store my x So I'm going to bring up the x, so alpha x, so it says x. Then I'm using the store button down here, right here. Store as A, alpha A. I'm going to store that as A. Now every time I type A into my calculator, I've got that negative 3.64 number. So I'm going from A to the center point. So I need to figure out that intersection. So second calculate intersect. It looks like it's at 0, but I'm going to double check. Putting it to there. Second guess. Third guess. Yep, it's at 0, like I thought. Okay? Then I want to find the area of this second bounded region. So that's this part right here. So we're going to start at 0 this time. And we're going to the second intersection point, or the third intersection point, which is right there. So first curve, second curve, guess. It's at this 1.64. So for B, I'm going to store that 1.6457 number. Again, we can't round it. We're going to keep it in there. So second quit. I want to store that x value. So bring up that x, and I'm going to store it as B. So I'm going to go from 0 to B on this one. This was my y1 equation. This was my y2 equation. So as I set this up, in the first part here, in this part of it, the top line is the blue line. So I'm going to start with y1, and I'm going to subtract out that second equation, which was y2. Then I'm going to add to that the second bit of graph. So for that one, the top line is the red line there. So I'm going to start with y2. Let's color code it if I'm going to color code it. So y2 minus the blue line y1. I need to type that into my calculator. So math 9. I want to go from A to 0, y2, or y1 minus y2. So alpha f4, y1 minus alpha f4, y2, dx. Then I'm taking that integral plus math 9, 0 to B, y2 minus y1, alpha f4, y2 minus math alpha f4, y1, dx. Enter. Graph it. Or not graph it. What was I doing? Enter. That's what I was looking for. 31.3 repeating there. So my answer is 31.333.